Hello class, this is your pre-lab video for lab 4. I passed it out in class today. So what I want you guys to do before you come to class on Wednesday is obviously read through the lab, which is page 25, and just read all of it so you're really familiar about what we're doing in class. Page 26, read through it. I don't want you to be too caught up in the equations that they give you. They look really difficult, and to be honest with you, we're gonna go through it in class. So read them, be familiar with them, but that is all in the analysis section. That's all in the analysis section on page 27 on, and we're gonna do all those calculations in class. So don't worry about that too much, okay? But just read it, but just don't fret over those. So what we're going to be doing in class is I'm going to be giving you guys a container, might be a Ziploc bag, of M&Ms. I've got peanut M&Ms, not peanut butter M&Ms, and mini M&Ms. So these right here are representing isotopes. So remember we talked about isotopes are going to be the same element, right? These are all M&Ms. But they're going to have a different number of neutrons, okay? So therefore their masses are going to be different, because remember neutrons weigh a lot in comparison to the whole atomic structure itself. The number of ones that I have in here is actually going to be pretty synonymous to copper. We're looking at copper 63, so the isotope copper 63, and then copper 65, okay? So we're looking at this right here as our copper sample. Okay, so some of the questions I want you guys to think through before we come to class that I would love for you guys to jot down some answers for. We're not going to turn them in, but we need to have a quick discussion on them before we move on forward with the lab. First of all, what are isotopes? Okay, we went through that in class today, Monday, and I kind of just briefly told you right here. All right, and then how many isotopes will you have in your mixture in this experiment? Again, we just kind of went through that. Which isotope does each candy represent? So I told you that we're looking at copper 63 and copper 65, right? Don't look at color. But which one do you think is going to be copper 63 versus copper 65? So think through that a little bit, okay? The next question, number 4. Why are most of the atomic masses on the periodic table not whole numbers? Remember we talked about that today, that it's an average. So again, why are they not whole numbers? Number 5. Are all isotopes stable? Okay, this answer is found in your book in 4.3, but are all isotopes stable? And explain, okay? Explain why they are or are not. Let's see. Okay, so the only question that I need you to have completely filled out on your lab before you come in is going to be under the procedure on page 26. You're going to answer number 1. Okay, you don't have to do anything with the lab to answer it. It's all about significant figures that we already covered in chapter 3. So I want you guys to look at that real closely. Go back and look at hold on. Look at the rules for significant figures from chapter 3 and answer number 1 for that, okay? So this is what I need you guys to have done for whenever you come to class on Wednesday. See, oh, and I will have plenty of M&Ms for you guys to also chew on. Chew on, that's gross. To eat. I'll have extra M&Ms for you guys to eat. You won't eat these because our hands are going to be all over them, but you guys can, I'll have extra. So, bye.